Am I right to start? Hi everybody, nice to see you all again. I'm Melanie, I'm from Federation University up in Ballarat, so I've done a lot of my work up at the uni rather than here in Melbourne. My supervisor is Manuel, who can't be with us today, but hello Manuel, we're taking a video. My topic is applying authorship profiling to identify online sexual predators, and what that is basically about is using machine learning to classify chat logs into whether or not it contains a predator or not. So, with the way the internet is growing in all of our homes, and children these days have more and more access, even with their mobile phones and their tablets and that sort of thing. Children can pretty much get on the internet anytime they like, and quite often that's unsupervised access as well. Some interesting studies showed, and these ones were in Australia in 2011, 34% of 11 to 16-year-olds had actually made friends through Facebook or some other chat medium with people online who they'd never previously met offline. So there was no guarantee that these people were, genuine children or not dangerous people. 5% of the children, and this is Australia as well, admitted that they'd actually gone to offline meetings with strangers who they'd never previously met. Very dangerous situations. So the problem we're dealing with here is it's really difficult for the law enforcement and for the parents to be able to monitor these conversations. At the moment, the popular method is that the police officers will send adults out there posing as children and waiting for, they don't actually entrap people, they don't go out there and approach predators, but they go into these chat rooms, and it doesn't take very long for them to be approached by dodgy people. There's also an organisation over in America called Perverted Justice. They do the same thing on a volunteer basis, and they arrange, they don't entrap the guys, they send the adults out there pretending to be 13-year-olds. These guys approach the kids, and over time the relationship escalates and the guys want to meet up with the kids. And so what they do is they say, okay then, I'll meet you after he offers, the meeting, and then they'll often arrange for police officers to be there when the guy arrives at the house, because it doesn't matter that these are actually adults. The fact is, his intention was that he thought he was meeting up with a 13-year-old. And I say he, it's a bit of a sexist thing, but the statistics out there are mostly men approaching young girls. There is some dangers for the boys as well, of course, but it's predominantly men and young girls. So the research goals I had for this project was to look at what's previously been done and further develop that. The machine learning has been applied really successfully in other areas as well to classify the age, the gender, and the first language of authors of texts. And there was competition organised by the PAN people, and I believe it stands for plagiarism, authorship, and natural language. Perhaps they have a competition every year where they do different kinds of digital text forensics competitions. In 2012, they did one on exactly this, detecting the predators within the chats. So my first goal was to build a classifier that had equal or better capabilities to what was produced in the PAN competition, because I've never built one of these classifiers before myself, so that was the first goal. And then after that, once we've got the classifier working and sorting out whether these chats contain a predator or not, explore the effectiveness of the different feature sets that you give to the classifier. So there's a number of different ways you can train your machine learning algorithm, and the way we approached it was there's a program called Language Inquiry and Word Count, and what that does is it analyses a text document by taking each word and comparing it to its own internal dictionary, and in its internal dictionary it maps words to different parts of speech like pronouns, adjectives, verbs, but it also has a whole range of categories that are psycholinguistic features which indicate the frame of thought of the author. There's categories that relate to family, categories that relate to social. There's a sexual category as well. And then once we've got the that set of features and we train the classifier with it, then we wanted to look at the potential for then looking within the chats to find behavioural patterns, because a lot of researchers have found that the predators seem to go through these phases where you've got the initial phase where they first approach the potential victim, and that's a phase of trust building and trying to get to know them and trying to win them over, and it's all very sort of nice and everything at that point. And then as the relationship evolves over time, it moves into a grooming stage where they start to introduce the idea of a more intimate relationship, and then on towards the actual, what could be considered the attack, where they actually ask the victims for explicit photos, show them explicit photos, try to arrange a meet-up, that kind of thing. With our data sources, it's not possible to get a hold of real predator-child victim chats, because that sort of stuff's just confidential. The police just don't let that sort of stuff out due to privacy and all of that kind of thing. So what we did is I went to the PAN competition website, where they already had all of these data sources prepared from their competition. And the way they prepared the data sources was they used the perverted justice logs, which were actually adults posing as children, or what we call pseudo-victims, with these real guys, and each one of the logs on their chat site actually did result in a real conviction. So they've only got actual convicted predators chat logs on their website. They also made the data set realistic in terms of what you might find in the real world, and large enough to sort of indicate the kind of things might be used in industrial applications. We had, I just need to scroll a little bit here. There's a little bit missing off this page. Let's scroll up. Oh.
No, I think if you use two fingers. That? If you put the cursor there.
Oh, that's better. Yes, great. Okay, that's what I was looking for. So the collection of, when we're training our machine learning classifiers, first thing you do is you give it a training data set that's labelled with predator or not predator, and it uses that training set to teach the classifier the right answers. Then you take a test data set and apply that to the classifier and see how well it goes. Our training set contained 28,169 logs, and the test one was 124,000 or so. Now, what was interesting about this was most of their chats they got from IRC, which was just general topic, computery topic sort of things. Only 9.7% of the chats in the training set were actually predator logs, and that's what you'd sort of expect to find in the real world. They're not that common, these guys, common enough, but not that common. So they really skewed the data set to be a real world representation, which meant we didn't have a lot of true positives to test on. And then for what we call false negatives, which is innocent conversations which get tagged as being predatory, they went to this website called Omegle. I'd never heard of it before, but apparently you log in and you say chat with someone, and it hooks you up randomly with one other person. So there always chats between two people, and quite often they're two adults talking about sexual topics, which is okay, they're allowed to. So they threw a few of those files in as well, just so that we had something to sort of compare with. And the first thing I did, these files were massive and they were in XML format, and I didn't need all of the XML tags, so I wrote a few Python scripts to remove the XML and anything that wasn't necessary to the conversation. We filtered out any conversation that wasn't between exactly two authors, because we didn't want the classifier using the fact that there's only two authors to say, well, as part of its classification. We ignored misspellings and other noise in the data, like long strings of unrecognised characters are often images, and I felt that the predators often asked girls for images, so the presence of an image in a chat log may actually be an indication that these guys are exchanging dodgy photos. And with the misspelling, very difficult because most people in chats don't really care too much about spelling, so you've got misspelling going on all over the place, and some misspelling where you get like the word no with lots of O's is actually, it has context. It's actually a more emphatic version of the word no. So we felt that leaving that in was valuable, whereas a lot of the other pan competitors did spell checking and all of that. Then I realised at one point, because we had a list of known author IDs, and I had all of these thousands of individual chats, and quite a lot of them were between the same pair of authors, the same guy and the same girl. And I just felt, because we wanted to look at behavioural patterns in the chats, that it would be beneficial to merge those same author chats into one large conversation, so you get more of a feel of how the conversation goes over the length of time, because these guys don't jump in and attack the girls on the first date usually. They'll meet up one day, then they'll get back on another day. So that was the idea of merging all of the chats, and that also did help a little bit with our processing time. All right, so the evaluation measures that we went by, in the classification world, we have what's called precision and recall. Precision, and you get a precision score. The output of my classifier gives me a precision score, a recall score, and an F measure, which I'll get to in a minute. Precision refers to the number of documents returned. So we said go out there and get predator chats. How many of the documents that are returned are actually the predator chats, and how and with the recall, it's more about getting everything you possibly can that's relevant, but we don't care if we get a few false positives. Whereas with the precision, you want to try and get as few false positives as you can, which means the expense of maybe letting a few predators go, because you don't want to be accusing the wrong people of suspicious behaviour. There's different calculations we can do with our F measure. The F measure is actually a harmonic mean of the precision and the recall together. So they weigh up both of these things, and then you get this F measure out of it. You can give different kind of parameters or different arguments to the F measure that will put more weight either on precision or recall, or you can have them equally weighted. For all of my early experiments, I had everything equally weighted. But when I started to compare my results to the pan competitors, I had to give a little bit more weighting to the precision side of things, because that was how they ranked their competitors, and that's what I needed to compare against. But in the real world, you'd have to just weigh up the situation and see what was appropriate for your needs. So then we ran our data sets through two different classifiers. We had support vector machines, and we had the neural network, which we used a multi-layer perceptron with we used the Wecker suite of AI machine learning algorithms, and just used pretty much the default values that came with those algorithms, except with the multi-layer perceptron, we gave it a slightly lower learning rate so that it would learn a little bit faster. And then we compared the classification accuracy between classifying all the individual chats and then the data set with the merged chats, and then wanted to have a little bit of a look into patterns that went on within the conversation, patterns of behaviour. So with our results, we found that the neural network, the multi-layer perceptron, hardly outperformed the SVM. It was minutely better by about 0.7%, but it took about 9 minutes longer than the support vector machine to run, which only took about 4 seconds. So, if in situations where like accuracy isn't of a critical nature, the support vector machine we found to be the better choice because it's a lot more efficient. When we compared our classifier results against the PAN 12 participants, when the F measure was equally weighted between precision and recall, we actually scored well above all of the results they got for the same measure. We were sitting on 0.9 something, and I think all of them were sitting on about 0.8. It was doesn't look like a huge difference, but it was a good result. But when we looked at the F measure that put more weight on the recall, we came in second by about 0.012. So we still did it still performed really well. And we found that was going to be a good algorithm to continue using for our other studies. Now, we would have liked to have looked a bit more into the chats line by line to see what kind of behavioural patterns we could find, but I actually, 1 minute, that's great, nearly there, that was a bit beyond my expertise at this point, and that's something I'm going to look at in future. So this is just basically a colour-coded breakdown of all of our different chat files and the number of lines, up to 150 lines, which ones were ends, the greens were classified as, so we classified the chat files line by line and found this sort of thing emerging. So just summing up, the choice of the classifier depends on whether you value accuracy or efficiency. Performance measures need to be relative to the task, precision or recall. Longer conversations give better results. Small differences can have significant impacts over large data sets. And the psycholinguistic attributes alone worked really well. Other people have used other things. Noise in the data didn't change much. And in the future, we're going to have a much closer look at the behavioural patterns and see how they relate to the stages the predators go through with the grooming and the initial contact and trust building, and see if we can map that to foraging and hunting behaviours in the natural world of animals and insects. And I'd just like to say thanks to Nectar for this great opportunity, and thanks to Manuel for some inspiring ideas. And I'm planning to continue working on this for the next few years, right through to PhD. Thanks, everyone. Yes.
So you mentioned there that the victim responses can impact the results, and I imagine that's true. Were you worried using, or did you notice using IRC chats and predator logs, that your IRC chats will mostly have adults talking to one another, and your predator logs will have the imitation of a child talking to an adult? So your machine learning could just find logs that have a child in them, rather than logs that have a child and a predator.
That's a good point, and we would really love to be able to run this with real children, but the data sets simply aren't available. So with this kind of stuff at the moment, kind of limited to what's actually out there. But you're dead right. Like, there's a lot of controversy about the use of these perverted justice sites, because also too, an adult posing as a child may not actually behave exactly like a child. They might think they are, but this psycholinguistic classification stuff has shown it can identify the age and gender of a person in other chats. So I would expect that we might see a bit of that in this as well.
The worry is you create a fantastic program with a high confidence and then you release it in the wild and you're just catching a bunch of children talking on Skype to one another.
This is true, but we would hope that if you're going to release it in the wild, that perhaps the law enforcement guys would get a hold of it and then that they'd run their own data on it, you know. But yeah.
Cool.
Thanks.
I'm interested in what the practical application of this is, because like most of the time these suspect chats are happening on stuff like IRC, which is anonymized and decentralized and not, you know, the logs are only present on the user's computers. So, you know, is it just used post hoc to identify behaviour patterns, or is the hope that it
Right, well, from our perspective here, we need to be very careful because we don't want to go out there and tell the law enforcement guys how to do their job. We don't want to step on anybody's toes, and we're not really qualified to say the best way that this could be used. Our idea is to produce the research so that then their guys can come along and say, all right, this is how we're going to apply it. But there's been a lot of talk by other researchers about possibly early alert systems, so maybe some software you could run on your computer, and it could perhaps, when the child's in a conversation, have a little pop-up go, hey, I don't think this person's really who they say they are. But you'd have to be terribly careful with that kind of thing. You don't want to go out there accusing the wrong people of the wrong code, because it's not 100% accurate, so there's always that chance that someone's, you know.
And that kind of software always has potential for abuse.
Absolutely, absolutely. Personally, I'd like to see it in the hands of the law enforcement guys who know how to handle it and what to do with it. Yeah.
I'd love to see it in the hands of parents. I mean, parents.
Yeah, parents too.
Parents would be great.
Oh.
Even if it was just an email to the parent saying, there's a
It's suspicious.
conversation going on your child's laptop.
I think that's the whole idea. Yeah. I think it's the whole idea for a lot of the researchers is to use it as a flagging system, so then the adults can go and then manually investigate. Yeah, absolutely.
Okay, thank you. I think we can
Thank you.
continue the
Yes,
discussion.
yes. Sorry.